let's move on to the H1 cohomology. Remember, we said that these cohomology groups are like the disjoint union of the cohomology group with respect to a covering, right? But then we need to identify the groups under these maps induced by refinement. In the case of the cohomology in degree 1 though, these maps turns out to be injective. So in a sense, you are only identifying cocycles that are already equal. So that's why it is a union. Right, these injections allow you to view this as a subgroup of this, and so we are identifying this with itself basically inside this group. Alright, so now we want to show that these maps are actually injections. So let's suppose that V is a refinement of U coming with some refining map here. Remember what it means, right? So let's say V consists of VI's and U consists of U alpha. What should the refining map send I to? Well, we will choose an index of U, right, that's such that there's an open set of that index containing VI. So here I would pick alpha. There are no other choice, but in general there might be. And for J here we see that U beta contains Vj, so that would send J to beta. Now, so to show that this map, this refining map, is injective, we need to first review what is this map. So an element in here is an equivalence class of one cocycle, but first of all they are one cochain. So on each of these intersection in the cover, right, we choose a section of the sheaf K. This gives us a tuples of section, one for each intersection. So what should its image be? Well, its image should also be tuple, so on each of the intersection Vij, we should choose a section. So what should the section be? So we look at the restriction map, right, and we see that I is mapped to alpha, J is mapped to beta. So this, whatever section this should be, should comes from the section that we pick on U alpha beta, and that was the section K alpha beta. So this should be K alpha beta restricted to Vij. Explicitly in formula we have, so on the Vij, the section we pick is KRI, RJ. But note that these are not just any one cochain, these has to be one cocycles. So let's review what it means for this to be one cocycles. Remember, a one cocycle should be in the kernel of this map, right, D, and this map D should send this tuple to a 2 cochain. So that's gonna be, we have to choose on each of these triple intersection a section, right? So the section is gonna be defined as follows. Here on each of the double intersection, we had a section, right? And now we choose for the triple intersection on this, we use a linear combination of this to get a section on the triple intersection. For this to be a one cocycle, this needs to be 0. In other words, for every indices alpha, beta, gamma, where this is defined, where this expression is defined, we should have the following. This is called the cocycle condition. Alright, so now to prove injectivity, we suppose that we have a one cocycle mapping to 0 here, it becomes a coboundary here. We need to show that it's actually a coboundary. So we want to show that it must be of the form H beta minus H alpha, right, for H alpha sections of K over U alpha. So here you might ask, hey, wait, don't we already have this from the cocycle condition? Can't we just take this to be H beta and this to be H alpha? Then voila, isn't this just H beta minus H alpha? So what's the problem with this? The problem is that this K gamma alpha is only defined on this intersection. So we can't just extend it blindly to the whole of U alpha, it's only defined here. But we need a section H alpha on the whole of U alpha. So what should we do? How about we just cover U alpha, right, with this U gamma maybe, and then glue all of these K gamma alpha sections together to get a whole section H alpha on U alpha, right? Sounds pretty good? But don't be happy too fast. It's not true that you can just glue anything you like, right? We need these to actually be compatible as this gamma vary. We need them to be compatible for us to be able to glue them to anything. So what happened is that we will modify these K's by some Fi's. So that's here's when we use this hypothesis that this maps to 0. Okay, so since this maps to 0, this means that this cocycle maps to a coboundary. So what does that mean? That means that there must exist sections Fi on Vi such that this KRIRJ must be equal to Fj minus Fi, because these form the image of this one cocycle, right? Okay, so we should have this, and by cocycle condition we can split this into K alpha Rj minus K alpha Ri, right? And so if we split this on the side and this on the side, we see that these two sections are compatible. Thus we see here for J, Vj intersect with U alpha, we have a section here. For Vi, we have a section here, and these sections are compatible on intersection. I should have made this intersect, right? And so they all glue together to a section H alpha. Alright, now to end this, we want to show that K alpha beta is H beta minus H alpha, so that this is a one coboundary. To do so, it suffices to check that they agree locally, so we'll cover U alpha beta by the intersection with the open set Vi, so that we can split this. By definition, this is Fi minus K beta Ri, right? And if we can cancel the Fi and see that this is just K alpha Ri minus K beta Ri. So this is just the cocycle condition. Alright, and I might have mixed up some index somewhere, but who cares? What matters is that we have shown the idea why this map must be injective. If a one cocycle here map to 0, right, map to a coboundary, then it must itself have been a coboundary. So since all of these map induced by refinement are injective, this H1 must itself just be a union over all of these different covering. Thus we had an explicit description of H1.